There are a couple different things that we can do when dividing polynomials, so you need to make sure that you're paying really close attention specifically to what it's being divided by, because that's going to change how the process looks, all right? Easiest is when we're dividing by a monomial, dividing by one term, okay? It's going to be a really simple process of just simplifying the fraction, okay? When we divide by a monomial, we are just going to take each term in the divisor, and we're going to simplify it with the denominator. When we have a monomial denominator, we can rewrite this as 3 separate fractions for each of the terms in the numerator. I can rewrite this as 10x squared over 5 minus 25x over 5 plus 35x over 5. Think of it as kind of undoing the whole adding fractions by having a common denominator. When you add fractions or subtract fractions with a common denominator, you leave the denominator alone, you just kind of add everything together in the numerator. Same thing here. I've got multiple terms being added and subtracted in the numerator over a common denominator. So I can split that apart, and it makes it really easy to see how you can simplify each corresponding item. So if I look at 10x squared over 5, how does that reduce? 2x squared. 10 to the 5 simplified, 2x squared. All right, 25x. Okay. And 35 over 5, 7. Okay? So when we're dividing by a monomial, it's just a matter of taking each term in the numerator and simplifying it by that monomial. Okay? Whether we have just a coefficient or a constant, or if we have a more complicated monomial, okay? Coefficients, variables, and exponents is still that same process. Okay? So looking at B, I want to take each term in the numerator and simplify it with the denominator. So 4x to the 4th over 4x to the 3rd leaves me with what? Just x. Now let's go to the next term in the numerator. Negative 7x to the 3rd simplified with 4x to the 3rd. It'll be negative 7 over 4. X to the 3rd divided by x to the 3rd. Those will both cancel. Negative 7 over 4 is all I'm left with. I can't simplify that fraction, so just leave it as it is. And then last term divided by the denominator. Three over x. 12 and 4 simplify to give me 3. Our quotient rule says we do what with our exponents? Subtract. So I end up with negative 1. That negative 1 moves that x to our denominator. Okay, using that negative x. All right, so there's our quotient. X minus 7/4 plus 3 over x. All right, last one. Close. Just 6 over a. The b's will cancel. 4 minus 4 is 0, so that eliminates. I'm just left with the a in the denominator. 9 over b, good. Okay, so that's dividing by a monomial. Okay, one term only in the denominator. Now, if I have more than one term, which as you can imagine is coming next, it's a little bit more involved. Okay, we're still kind of looking at the same idea of dividing each term by the divisor, but we're going to be focusing on just a part of the divisor, and then there's a couple other steps that go with it. It's very similar to the standard division algorithm. We're going to set it up in the same way. We're going to do the division. There's 2 different ways that we can do polynomial division when we've got a non-monomial denominator. Okay? First thing we're going to do is we're going to do long division. Okay? Long division. Okay? Polynomial long division, which apparently I can't spell division. All right? we're going to set it up like the standard long division algorithm. If I have something, I have a divisor divided by, dividend divided by a divisor. Okay? Whatever's being divided, we kind of just set up this house, kind of like the square root. What's up, man? A variable. Thank you. There you go. All right. So we set up our standard long division algorithm. I know in some countries they set up a little bit differently. I can't do it that way. Okay. So we set up our standard long division algorithm. All right. And what we're going to do is we're going to focus on that division that we did before, where we have the term divided by the divisor. But I'm only going to focus on the first term of the divisor when I'm doing the division. Okay? So just like on the last one where we did x to the fourth divided by x to the third, and so on, I'm going to do the same thing. I'm going to do 2k squared divided by k. All right? First term of my dividend divided by the first term of my divisor. What does that give me? 2k. Okay? Now, that is the first term of my quotient. Now, just for simplicity, we always line it up with whatever our power is. So since I have a 2k to the first power, it's going to line up with my 17k to the first power. Just keep everything neat and nice and in line. Now, similar to our long division algorithm with just integers, we're going to take this first value in our coefficient, in our quotient, and we're going to multiply it by both terms in our divisor. Okay? So, 2k times k gives me what? 2k squared. 2k squared. 2k times 6. Okay, we're going to take that and we're going to subtract. Now this is the part where most people are going to make the mistake, because this subtraction, especially when things start becoming negative, get really, really tricky, and you need to slow down and take your time and look at each piece individually. You will subtract both of these terms from your dividend. Okay, so 2k squared minus 2k squared, 0. That will always cancel. If it doesn't, don't force it. Go back and figure out how you messed up. Okay? The biggest mistake is you could have caught it there, but you just said, well, it has to cancel. Make sure it actually does. Don't force it. Go back and fix it. If it doesn't cancel, you did something wrong. 17 minus 12. 5. And then I'm going to bring down my next term. And I'm going to continue with that process. Okay, I'm going to continue with that process. Again, I'm going to look at the first term of my dividend and the first term of my divisor, and I'm going to do that division again. I have 5k divided by k gives me 5. So that's the next term of my quotient, plus 5. Okay, that's the next term of my quotient. So now what I'm going to do is I'm going to take this, I'm going to multiply again, here and here. 5 times k. 5 times 6, 30. And then when I subtract, it all cancels out. And I'm left with no remainder. That will not always be the case. It's important to be able to identify whether or not we have a remainder. So that's my quotient. 2k plus 5 is my quotient.
And to write the remainder, it would be, like, say, like we had a remainder, like 21, it would be 21 over 6.
We'll get one. We'll get a remainder. Okay? So, there's our quotient. When we divide, plus 5. Okay? That's long division. Now, this one and ones like it can be solved using synthetic division, which we're going to do next. But before we do that, any questions on this process? Okay? Not all of our division problems can be solved with long division. Some of them can be solved with synthetic. The process for both of these is important because they have very different roles. Okay? Long division is something that you can do with all of them. Okay, so it's a good catch-all. Always can do the long division algorithm. Synthetic division plays into some other features with polynomials later. Okay, so in the second semester there'll be things that we delve into that we'll need synthetic division for, because it is a shortcut that allows us to find very important pieces of information about polynomials, specifically ones with higher degrees. Okay, any of you that took AAT, you should be familiar with some of the useful things with synthetic division. Okay, so the way synthetic division works is we're going to be focusing mostly on the constant of our divisor, and we're going to be focusing on the coefficients and the constants. We're going to get rid of the exponents. We're going to get rid of the variables. But we have to be very careful in our division. Whether we're doing long or synthetic, we have to make sure we check two things. One, that our divisor, dividend, is in standard form. Descending order of powers, highest to lowest. Am I in standard form? Okay. Second thing we have to check is that all of our exponents are present. That we're not missing any of our degrees from our highest all the way down to our lowest. Am I missing anything? What? I'm missing the square term. So we need to fill in a placeholder. What could I add? There you go. I can add a 0x squared to get that placeholder. That placeholder is very important. Okay, add in that 0 so that we still have that squared term. And then now we're just going to get rid of all of the variables, the exponents, and we're just going to focus on the coefficients and the constants. So we strip those out, and then we're going to focus on something else. I'm going to add this in here. All right. In order to do synthetic division, our divisor has to be a linear binomial. How can I tell if a expression is linear? How can I tell if an expression is linear?
Slope.
Okay, or the exponent is what? Is 1. Okay, our variable has an exponent of 1. Okay, how do I know it's a binomial? It has 2 terms. So an exponent of 1, and it has 2 terms. Okay, a linear binomial. The second requirement in order to do synthetic division is that the leading coefficient must be 1.
Wait, can you repeat how do you know?
Linear is the exponent is 1. Binomial means 2 terms. So linear is a line, binomial 2 terms.
So if it was x.
Synthetic, I have to do long. Okay. Leading coefficient must be 1, not negative 1. 1. Okay? We say that this is in the form of x minus k. Okay? If it's in that form, then we can do synthetic division. Now, it's very important to note the x minus k, because instead of using a positive 2, what am I going to use instead? A negative 2. And the reason we do that is because long division, we're subtracting. Every time we do that multiplication, we get that new line, we're subtracting it from the dividend to get our new dividend. Synthetic division, we do addition instead. Okay? So we're going to still do multiplication. We're going to do addition instead. All right? Everything in the first row, everything in this row gets added to what's above it. Okay? Or I guess second row. Everything in the second row gets added to the first to give us our result in the bottom. Everything in the bottom is going to get multiplied by whatever we have in this box. So this is going to get multiplied. Where's that? It's going to be multiplied by negative 2. And we're just going to go down the line, starting with 4. Okay? 4 plus nothing is 4. So we just bring that first one down. Negative 2 times 4. That's going to go into the next row or next column. And I'm just going to repeat the process. 0 plus negative 8. Negative 8, and then multiply again. Negative 2 times negative 8. 16. What am I going to do with 3 and 16? Add them. What am I going to do with 19? Negative 2 gives me what? Then what? Add, and I get 46. Okay? So this bottom row is now my quotient. That gives me my quotient. All of this. All of this here is my quotient. But now we need to write it. We need to put the variables back in. The last number is always the remainder. And then we have to figure out, okay, well, what degree are we going to start with? So you can think back. If I do 4x to the third divided by x, what do I end up with? 4x squared. And then what's the next power after x squared? And then after that? None. And then I have my remainder. 4x squared minus 8x plus 19. And then here's the fun part with the remainder, okay? Positive or negative is going to show up what this sign is here. So here's going to be minus. Your remainder over your divisor. So you have your quotient plus or minus the remainder over the divisor. Quotient. Oopsies. Got that up. I wanted my highlighter. Highlighter. There we go. Quotient. Remainder. And divisor. Okay, so when you have a remainder, whether you're doing long division or synthetic division, that's how you write your solution with a remainder. If there's no remainder, then you don't need that last part. Okay, it's just a quote. If you have a remainder, you need to write it in this notation. Okay. Long division. So synthetic division here, on the last one, we could have done synthetic division as well because it's a linear binomial with a leading coefficient of 1. Okay, so when you have that, you can do either one. This is our last function combination. We've done addition, we've done subtraction, we've done multiplication. Now we've got division, but it's the same process. We look at the functions, and then we do whatever the indicated operation is. Here it wants us to divide. It wants us to divide the two expressions. F of x divided by g of x. Can I do synthetic division with this? No, I cannot. Why? I have a leading coefficient other than 1, so I can't do synthetic. It's a linear binomial, but I don't have a leading coefficient of 1, so I can't do synthetic division. The extra effort involved in it would not be worth the time saved by doing synthetic division.
Well, yeah, but could you make it work?
Possibly. I'd have to try it. I honestly don't know. Maybe. Alright, so I have to do long division. 2x plus 5 going into 2x squared plus 17x plus 30, okay? In standard form, I'm not missing any power, so I don't need any placeholder zeros, okay? What do I do first? I'm going to divide two things. What two things?
2x and 2x to the square.
Okay. Where do I put that x?
You put it below the 2x.
Right.
Above the 17. What am I going to do with that x?
Multiply.
Multiply here and here. Now what?
We can subtract
The last one was a binomial.
Don't you have to
Or a linear binomial with least coefficient of 1.
Don't you
This
have
one's
to-
2x. I don't know why it's 22. I'm losing my mind.
Yeah, why is it 22?
Oh,
There, sorry.
that was me. Don't you have to bring down the cos thirds?
Yes. Okay, now what?
12x.
12x by 2x.
Oh, you gotta stay over.
Okay? What's my remainder? Zero.
Hey. So the answer is x plus.
So,
Oh, wait. I think it's not. Can you just.
that'll be for the second part,
Okay.
yes.
That's the answer, right?
So, f divided by g of x gives us a quotient of x plus 6. So that's the first part. Second part says, now I want f divided by g of negative 1. So I did the long division. I've already got f divided by g. So now in order to evaluate this, what do I do with that negative 1? Plug it in for x. Okay? Let's do green. Okay? So f divided by g of negative 1 is negative 1 plus 6, which gives me 5. Easy peasy,
That
right?
was easy. Score.
Cool. You have an assignment. Have fun.